Hey everyone, this is Miss Ursary, and I am starting this week off with a lesson on water. So we're going to spend this whole week talking a lot about water and the effects it has on us and the water that we drink every day and how that water actually comes to you. Okay, so I know that most of you just turn on that tap water and out comes your water and it's clean and it tastes good and you really don't think much about that. But 2 summers ago, I went to Central Arkansas Water and did a workshop. And through that, I learned all of the processes that go through providing us with fresh drinking water. And there's a lot of them. And they have to continually monitor our water to make sure that everything is safe for us. So I spent about a whole week learning everything, the behind the scenes, got to go into the actual facility and watch how everything works. And it is a very, very long process. And it is a 24-hour job. There are people that are there at the Central Arkansas Water Facility 24 hours a day, maintaining, making sure there's no leaks, no pipes breaking, because things happen and they have to get on things quickly when a water pipe breaks. You know, sometimes you might have been in your house and you heard, oh, we have to boil our water. You're under a water boil. Well, there's reasons behind why that happens. And so we're going to go through this chapter and we're going to section, excuse me, and figure out exactly what's going on and how they get that fresh water to you every day. So I'm going to share my screen with you here for a minute, and we are going to look at what is the behind the scenes and how important water is to our actual uh, daily living. Okay, everybody needs water for everything. We wash clothes with it, we drink it, we cook with it. 70% of our body is actually made of water, so it's vitally important that we know the background behind how all the processes go. So first of all, water actually covers 71% of the Earth's surface. It is a compound. Most people sometimes think water is an element, but no, water is a compound made of two hydrogens and an oxygen. It is a pure substance. So we've been talking about pure substances and mixtures and things like that. So water is actually a pure substance because it is a compound. It is often referred to as the universal solvent. The reason for that is because water can dissolve in most things. It dissolves more things than anything we actually come in contact with. So that's why it's known as the universal solvent. Now, the water that we encounter on a daily basis is a mixture of pure water and other things dissolved in it. Therefore, drinking water, lake water, and ocean water are all examples of solutions. So when we talk about just water itself, it is a compound. But then when we look at water and we classify it as either drinking water, lake water, and ocean water, there's actually stuff that's mixed in with that water. So therefore it becomes a homogeneous mixture, or we call it sometimes a solution. Now, what is a solvent? I used that word a minute ago. It is a solution that is present in the greatest amount. It is a substance in which the solute is dissolved. Now, most people think of a solute that it has to be a solid. That's not necessarily the case. A solute can actually be another liquid, but it's in a smaller quantity. Okay, water is going to be the larger quantity if it's the solvent. So anytime we use the word solvent, we are referencing something that is dissolving something else in a large quantity. Okay, so the solute is the minor component in a solution. Okay, so if you look down here, here we have a chemical. Okay, and this is our solute. And now here we have water, and I think this is copper chloride, and water is going to be our solvent. So here's your solute, and then there's your solvent. Okay, then when you mix them together, you now have a solution of copper chloride. Okay, because you've dissolved it, you've put it in water, and you've made it less concentrated. Okay, um, in the solid form, it's very concentrated. You put it in water, it does dilute it a little bit, but that's okay. And this water makes it into a liquid, and that's usually when we do reactions and things like that. We need it in the liquid form. So most of the time, you're going to see stuff in here, it's going to be in the liquid form. Okay. Now, many liquid solutions contain water as the solvent. Ocean water is a water solution that contains many salts. Body fluids are also water solutions. Remember me saying a little bit ago that your body is 70% water. So a lot of the processes that your body undergo and most of the chemical reactions that occur in your body are water-based chemical reactions, or because they call them aqueous solutions because it's with water. So anytime you hear the term aqueous solution, that refers to something being dissolved in water. Now, drinking water, okay? We all know that water is not safe to drink, okay? Stuff that comes out of the tap water is, but if you just go out into a lake and just start drinking water, you don't know necessarily that that's going to be healthy for you because you don't know the bacteria and the things that are living in the water. A lot of times you'll hear reports of E. coli in some of the lakes because bacteria does grow, and if they don't treat that, if they don't test that on a regular basis, bacteria can grow within our lakes. It isn't the water molecules themselves that are not safe to drink, but rather there are things dissolved in the water that makes it unsafe. Therefore, water that we drink, shower in, clean our dishes with, etc., it must undergo a treatment process to ensure it's clean enough for us to use. So we have to go through this process to protect the public because we don't want people getting sick. Often they tell you when you go to another country, they often say bring bottled water. The reason behind that is because they may not clean the water the same way that they do here. Not necessarily saying that every foreign country you go to has dirty water, but sometimes they use different chemicals or they leave minerals in there, and your body has not adjusted to that. Your body's not used to that. So some of these minerals that other countries may leave in the water can actually hurt your GI tract a little bit and cause you some upset stomach and things like that. So that's why they tell you it's important that when you go to a foreign country, sometimes you have to regulate your body and bring some bottled water so that it protects you because you don't know necessarily what minerals they are putting in the water. All right, so now we're going to transition over here to the drinking water treatment process, okay? And in this process, several things have to happen. It has to undergo several things for this to occur. So there are many impurities in raw water. These impurities can be grouped into three categories: a physical, chemical, and biological. So your physical are materials that do not dissolve in water and make the water appear dirty, like mud, algae, things like that. Certain salts and things like that. So it may not appear very clear because of the things that are not dissolved in the water. Then you have your chemical. There are substances dissolved in the water from both natural and man-made processes, okay? And then your biological, I talked a little bit about that a little bit ago about E. coli. So viruses, bacteria, algae, and other small living organisms can end up in these lakes, okay, that your water comes from. So no chemically pure water entirely free from any other materials does not exist in nature. It doesn't. There's no water out there that is as clean as tap water in any body of water that you can get around the United States. It's going to have something in it. It's going to have something dissolved in it. Distilled water is usually flat and tasteless, and few people enjoy drinking distilled water. It would probably be prohibitively expensive and possibly unhealthy to purify our entire water supply to that level. So what they're saying is in order to distill where everybody would be drinking distilled water and ideally have distilled water, that would cost an enormous amount of money to do, and then your water would be too expensive for you to even purchase. So that's why we don't make that accessible for all people. Now you can buy it in the grocery store, but that's in small quantities, okay? It's not providing it, showering in it, bathing in it, washing your car, things like that, readily using this water. There's not a necessity for it to all be distilled, okay? Natural water, which we call free from any man-made additives, if it still exists, contains concentrations of minerals such as calcium, magnesium, and iron, which are beneficial to human health in small quantities. So just because things are beneficial doesn't always necessarily mean you want to take them in large quantities, right? So yes, calcium is extremely beneficial to our body, but you can also get too much calcium. And in that case, certain diseases actually stem from trace elements. These are called trace elements. Sometimes these elements, if they are more concentrated in your body, it can cause other diseases. So you have to be careful not to overload your system with too much calcium or too much magnesium or even too much iron. Okay, so they can, you know, some of you often heard of sometimes if you don't have enough iron, you're anemic. Okay, that's one thing that happens if you don't have enough. But there are cases where people take too much or too many minerals, and then they're putting a toxic level in their body, and then that can lead to other diseases and things that are not good for us. Okay, so large particles and debris are removed from the raw water by traveling screens just as the water enters the treatment facility. So you'll see, I've been to this, it's a huge, huge facility, and what they do is as the water's coming in, there is these large screens that the water actually goes through, and it prevents all of like your sticks and things like that, so they don't have to worry about treating for sticks. So it actually blocks all of that debris and prevents that stuff from actually entering into the pipes that will go to the treatment facility. There are 5 different processes our water undergoes. Okay, so you start out with coagulation, then flocculation, then sedimentation, filtration, disinfection, and fluoridation. So these are the topics that I'm going to talk about in the next few slides, and what actually happens when water's going through these different processes. So in coagulation, so here's a picture right here. Water's mixed with chemicals, okay, known as coagulants. Coagulants make the small physical particles in the water clump together. Okay, we're going to do a lab on this in a next couple of days where we use alum. Okay, aluminum sulfate, and actually that's what they use at the treatment facility. They use big, huge things of alum, and it churns in the water. And so what it does is when it's churning and it sits in these sedimentation tanks, the process of this coagulation is for these dirt particles, these minerals that are dissolved in the water that you cannot see. It actually attaches itself to these, the coagulants actually attach themselves to these minerals and make them heavy enough that they actually fall to the bottom of the pool area that the water's sitting in. And so when that happens, now the water can travel because we're pulling all of those particles. It's much easier to filter if you have large particles that are being pulled out of the water. Okay? Now, what I just talked about, alum, aluminum sulfate, it's polyaluminum chloride and a group of chemicals known as polyelectrolytes. So a large charge attracts negatively charged clay particles, okay? And as you can see in this diagram, that's what's happening, and it attaches, okay? It attaches to these particles and makes them so heavy that they actually fall to the bottom of the sediment pool. Okay, so the large charge on a small ion. So you have aluminum and you have iron. And what happens is these attach and then they fall down to the bottom. Okay, so gentle mixing to form larger groups of particles known as floc. Okay, so as you can see, high energy here. So it's actually stirring things up. So these little windmill things are in there and they're churning the water, making it attached to the particles, getting it all mixed in. Okay, then there's stage 2 where it's in the chamber, and then stage 3, all of that in the flocculation. So there's gentle mixing to form larger groups of particles known as floc. The thicker, denser floc floats down and settles out of the water in large tanks, which is called a sedimentation tank. Or it is removed during the next stage, which is filtration. So not all the sediment will actually get removed in the sedimentation process. That's why you have to go to the filtration process next. So this right here is actually the facility that I toured in Central Arkansas Water. Now, if you look way in the back, you can see this thing up here. And what happens is that is one of those things that's putting the alum into the water and churning it. And then you see these pools right here. Okay, these are your sedimentation pools. And what happens is this water sits in this sedimentation pool. Okay, and then now it's going to go to and it collects at the bottom, and there's these little things right here that actually scrape the bottom and get that sediment out of the pool. Okay, so it's like they just these big grates, and they're going to scrape that sediment right out of the pool. So it's going to travel, and as you can see, the water will travel to several different sedimentation pools along the way. Okay, so the removal of the remaining floc, other chemical and physical impurities, most of the biological impurities, and then the dual media filters are layers of sand and anthracite. So this is the filtration process, okay? So what happens in the filtration process? So here you have your perforated laterals, okay? That's that little screen is gonna wipe all that stuff off. Now you have your wash troughs, okay? And then this is your filter tank. So then you have coal, which is anthracite, then you have sand, and then you have coarse gravel down here. And all that is going to pull all of the rest of that sediment out that maybe when it went to the next pool of sedimentation, you didn't get all of those particles. They were not necessarily heavy enough to fall down. So now what you're doing is a process called filtration. You're going to get all of those little microorganisms, the bacteria, all that stuff that you can't see. You're going to filter all that out of there. Okay. Now, the addition of chemical chlorine, so this is going to be your bleaching time. This is where you're trying to get those really, really, really small microorganisms that you can't see, that you can't filter out. Then you're going to add this chemical of chlorine, okay? The chemical is added to our water at different points in the treatment process. When chlorine dioxide is added at the beginning, which they call pre-chlorination, after the filtration stage, it's known as post-chlorination, the addition of calcium hypochlorite, which is actually in bleach, if you didn't know that. So they're actually bleaching the water to try to get any of those microorganisms that still may be in there that were too small and kind of made it through the next sediment pool because it didn't filter off. So we just saw that filtration process. And maybe sometimes there's going to be viruses and bacteria that gets through that they couldn't necessarily filter. So then that's why they do this post-chlorination process, which allows us to bleach or kill any bacteria that is still remaining in the water. Now, one of the last steps is fluoridation. Yes, they're putting fluoride in your water because a lot of times when we're drinking water, you want that fluoride in there to help with your teeth. It actually puts a barrier on your teeth. It's very healthy for you. So community water systems in the United States use one of 3 additives for water fluoridation. Decisions on which additive to use are based on cost of product handling requirements, and space availability and equipment, okay? Hydrofluorosilicic acid, HFS, and sodium silicofluoride is automatically fed at 0.7 milligrams per liter following the filtration stage. For this is the process required by the state of Arkansas. Now, like I said, not all states have the same process, okay? But for the state of Arkansas, hydrofluorosilic acid, okay, is added, and sodium silicofluoride is added, okay, and that's the amount that it's added per liter, okay. Now, the other thing that Central Arkansas Water does that some people don't, and this is where you can get in trouble if you don't use this, is they use an anti-corrosion procedure. The blended phosphates are mixed of zinc-based phosphates and are used as an additive to eliminate or prevent corrosion, as well as used to isolate and hold unwanted impurities from getting into the water system, okay? So this prevents your copper pipes from having issues, getting corroded. It also prevents along the way, if something gets into the copper pipes, it actually protects you, okay? So zinc phosphate solution is added to prevent corrosion of pipes. Right now in Ward, we've been having some issues with pinhole leaks getting into the copper pipes, and people are having to redo their whole copper pipe system, $4,000 to $5,000. And the plumbers are very upset because they think that the Ward Water Department is not adding the proper chemicals to prevent that corrosion, but they're coming back and saying we are doing our job. So there's a lot of dissension right now between Ward water system and the community that deals in the city of Ward. So Grand Prairie is not included in that because they're on this is the people in the city limits that are having a lot of these issues. So I haven't heard recently what the latest is on that, but there are some concerns about why people's water pipes keep getting pinhole leaks. So there is some speculation that they're not adding, say, maybe the zinc phosphate that they need to add to do that. I'm not sure. I haven't really done the research on it, so I don't know. That's just what I've heard through the news and things like that. And then I have some other friends who have had similar issues and have had to have their whole piping redone. So a lot of people are upset and they feel that somebody's not being forthcoming and honest. But like I said, I'm not really involved in it because I don't have Ward Water. I have Grand Prairie, so I haven't had any trouble. But there's just been a lot of arguing between the two groups over that. So water is a big deal, okay? Water is a big deal in our lives. It's very important. So I hope you enjoyed that lesson on water. We're going to be diving into some more water. Like I said, starting, I think, in a couple days, we're going to have a water treatment lab that we're going to be working on. And I'll have that video out to you as well. And then you can kind of see the process that the Central Arkansas Water went through and the process that your current water system in Cabot goes through. They have to monitor the water, they have to test it, they have to undergo a lot of different things to get us good drinking water. So it's important that we stay informed, and it's important that we understand really where things are coming from. So I really enjoyed being with you guys today. I hope to see you on Monday for our Google Meet. All right, thank you.